Good afternoon, everyone. I'd like to thank you all for joining us today in our continuing education series. Today our featured topic is inspection and cleaning. My name is Jessica Fetcherhoyt, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about inspection and cleaning is Joseph Cairone. Joseph is a product manager for the Adtell Group, offering over 20 years of hands-on experience in the fiber industry. Joseph will be discussing the importance of proper connector cleaning and inspection and the various methods available. When Joseph is finished, we will take questions from the GoToWebinar question box, which is located at the bottom of your screen. We will have a question and answer session. Thank you again for joining us today, and at this time I turn the presentation over to Joseph.
Thank you, Jessica. Good afternoon, everybody. And I'm Joe Cairone, and I'm going to go over connector inspection and cleaning for fiber optic connectors. So let's just get right into it. So there's going to be 3 or 4 topics that I'm trying to cover today. Basic connectors, basic polish, types of connector contamination, and also methods of connector inspection, and the methods of connector cleaning that are out there and available to us. So as you see here in the first slide, you have 2 of the basic types of connectors that we have here, and when I say basic, I'm talking about the 2.5 millimeter ferrule connectors as well as the 1.25 millimeter connector ferrules. The first picture in the top left, you have your FC or Frank Charlie connectors. The next one is SC or Sam Charlie, and the furthest one to the top left, or excuse me, top right, is the ST or Sam Tom connectors. Below those, you have your LC connectors, Larry Charlie. The middle ones is the MU, and the bottom right is the MTRJ connector, and that has a double ferrule in that. So this probably represents about 80 to 90% of the connectors that you're going to see out in the field. There are other types of connectors. There are termini connectors that are used in 39 888s, 29 504 connectors. Similar cleaning methods and inspection methods of these, but for the most part, these are the main connectors that you're going to see out in the field, and that's what we're going to concentrate on today. Here we have the connector polishes that you're going to see out in the field. Now, this one, there's 5 that are listed here, the flat, PC, XPC, UPC, and APC. But what I want you to take note on is under the specification, you're going to notice the back reflection. That's what's really important here when it comes to connector polish. You can see the PC connector. It shows that it's got a better than -30 dB back reflection. And just to let you know, the larger the negative number, the better the back reflection. Basically what it's saying is less signal is coming back when it's sent out. So nowadays, there's really 3 connectors that you're going to see out in the field. You can see the PC polish, the UPC polish, as well as the APC polish. PC is usually relegated for your multi-mode connectors, where the UPC and the APC are for your single mode. And again, the UPC, you have that back reflection of -55 dB, and definitely on the APC, you have a -70 dB on your back reflection. One thing you want to note, if you ever come across like -15, -16, that's an open air connection. So that's a connector that you're shooting, and it is coming in contact with open air, and that's why you're going to have such a high reflection. 3 areas that determine a correct polish. There's 3 things you're going to look at: your apex offset, your radius of curvature, and your undercut or protrusion of the glass in the ferrule. So the main differences of these three different areas here. So we're going to look at the radius of curvature, and what the radius of curvature measures is how round the ferrule tip when it's polished. And that radius is usually around 20 inches from a theoretical center, and you want to make sure that that's uniform. And I'm going to show you in the next slide, it will show you what the parameters or the specs are. But that radius of curvature needs to fall into a certain spec in order for it to get the desired result that you need. The next thing is you want to look at is the apex offset. And you can see that apex offset at the top where it shows a dotted line of where the fiber comes out of the ferrule, and then it also shows the second dotted line to the left of that that shows where the fiber actually comes out. So ideally you want to have that fiber dotted line match up with the original dotted line that's in the middle of the ferrule, and for it to be at the top or the apex of that radius of curvature. And that's what's going to give you the best results. And then the last thing that you want to look at is your undercut or protrusion. When you're polishing these connectors, you can have the glass below the ferrule tip, or you can have it protrude above the ferrule or the ceramic. And there's, again, there's a parameter that needs to lie in order for the connector to perform properly. And again, we're talking about microns, so it's a really small measurement here that you're looking at, but it can make a difference between high attenuation or back reflection or the proper attenuation and back reflection. So you see here the table that shows what the radius of curvature needs to fall within. The fiber height would be your protrusion or undercut, and obviously the apex offset is how centered is the fiber to the top of the radius of the curvature there. And you'll see that you can see that they are the IEC specs, and this one happens to be the SC type. Generally, all your 2.5 millimeter ferrules will have the same requirements. Your 1.25 or LCMUs, there's a little bit of a different spec that they go by, but again, the main thing that you want to get from this is if you have one polished end mating with a second polished end and they meet these specs, you should have the best possible attenuation and back reflection that you can get. That's really what you want to take away from this. Now what we're going to do is we're going to focus on how the connection actually takes place in an adapter, and the factors that are involved in having this occur and what you can kind of expect. Generally you cannot see this because it's inside an adapter. This is like a cutaway model here. So on the left hand side in the purple you see, or purple, yeah, I guess you're going to say purple, it's the fiber connector, and it's already one side, that's an LC connector that's already inserted into a bulkhead adapter. The gray area that's sticking out, that's the ferrule. It's 1.25 millimeter ferrule. Inside of that is your fiber. And if you can see, I think if I hit another, okay, you can see now the ferrule is marked, and now you have the alignment sleeve. Now both the alignment sleeve and the ferrule are made of zirconia or ceramic material. So they're very accurate, and the tolerance when they make these components are very, very accurate, and that's what allows us to have these small tolerances that makes for a good connection. So we're going to have, as you see, the other connector came in and made a connection, and there's actually a physical contact between the two ferrule ends. They do mate up and meet each other, and that's why the PC is physical connection, or UPC is the ultra physical connection, or physical contact. And that area in the orange box is where that occurs. So you want to be, that's why it's very important that, as we go along here, as far as the cleaning aspect goes, you want to make sure that the end faces are very clean. Average pressures when these two connectors come together, just from the actual mating, when they click in, is about 45,000 psi per square inch. So, and it's mainly because it's such a small surface area. That's why the pressure is so high there. So you can imagine with that amount of pressure, any type of dirt, whether it's microscopic or larger, can really cause problems with your end face. So just good to remember that the fiber connectors are really the weakest point of your fiber network. So that's where a lot of the problems occur. So that's why keeping these clean and free of dirt and debris makes a big difference. The three basic principles you could say for connections, and you got to make sure you have good core alignment or perfect core alignment, and they do make physical contact. And you want to make sure that the connector has got a pristine interface, very clean on the end. And you can see where it shows that the signal's coming from one connector to the other connector. When there's nothing in its way, the light's going to transmit, and there should be minimal attenuation and minimal back reflection. So, then that would be a good. Let me go back to that. And that's a good connection. That's what it looks like. Good connection. There's no issues with it. So now we're going to go through what makes something for as far as a bad connection. So, and basically what's going to happen is keeping all things the same. The polish is good. The three IEC parameters are met. You're going to bring another connection in there and connect it. But now this one, the only difference is there's dirt. And that's going to come in, and you can see what happens. When there's dirt in the way, that physical contact. It's like looking out a window that's dirty. You're going to not be able to see through it, or it's going to reflect stuff back from it, almost like a mirror. You can kind of draw that conclusion. It's a mirror. You're seeing a reflection, and that's what's getting back because you're not being able to look through that mirror or the window. So, and that's what dirt presents for a fiber optic network here. So there's equipment that's available for us to do this visual inspection first before we clean. One thing you always want to do is inspect. And you see the three general type of inspection equipment here. Top left is a regular fiber microscope. Bottom middle is an inspection probe that can plug into a unit that has a USB interface. And top right is a self-contained inspection probe with display. And you can see, there are the three, basic visual inspection equipment that's available for you. So your fiber microscope, this is a direct end-face inspection where you're going to take the cable that you have that you're going to look at, and you're going to plug it into the left side of the inspection probe, and you're going to look in on the eyepiece on the right-hand side, and there's a light that is illuminated, and you're going to be able to see the end face. These typically are 200 or 400X models. 200 was, state-of-the-art 15, 20 years ago. 400 is, pretty much commonplace now. Anything less than 400, you really don't see as much anymore. Drawback from this type of inspection piece is you can't inspect the bulkhead connectors that are on the other side of what you're connecting to. Patch cords it's really good for. You can use it out in the field. And the other thing is you cannot document what you're seeing. So this is good for a quick check if you don't have to document. And it's recommended, 400X minimum for your single mode fiber. You can use 200, but the cost between the two anymore, it's worth going up to the 400X. Now your video inspection probe, we're going to show both of them here, and you can see the real positive here is you can toggle between 200 and 400 with these units. But you can use these to inspect patch cords as well as bulkheads. And when I said bulkheads, it's anything that has an adapter that you have to plug into, and you can't get your inspection probe right on that tip of the fiber by pulling out. Because a lot of times you can't go into the back end of a bulkhead and pull the connection or the patch cord off. So you're going to have to use a special tip for bulkheads to inspect that, but you'll be able to do that with the inspection probes. There's a variety of tips that are available out there, and for all the different connections and bulkhead types that are available. And the other main thing with this particular type of inspection instrument is the documentation. You can save these to a file and then print out a report. The one on the right, top right, self-contained, and that specific unit, you can look at the your end face, save the picture, and then there's you have to name the file, and there you go, you've documented. The other one on the bottom, or the VIP 45, you can plug that into a computer, or you can plug it into, in this case, an OTDR, and you can get your results, save them, document them. The one thing that the VIP 45 has, it also has pass-fail analysis software that goes along with it. So, and again, in that pass analysis software uses that uses another IEC spec to determine what's considered passing and what's failing, and that's really great. Nowadays, everybody is pushing for documentation for when you hand over your results. You know that when it left your hands, everything was in working order, and here's my proof that it was in working order. So that's a real important going forward these days. Now we're going to look at the different types of connector contaminants. What you can see out in the field, and kind of gives you an idea just based on what you see. It could give you an indication of where the contamination came from. Dirt. Dirt comes from anywhere. It's floating around in the sky. It's it's dust. Any type of dirt. Oil, and generally when you're talking about oil, it's probably from somebody's hand. Like your hands always has a little bit of oil on it, but there could be fiber connections in a machine shop, and with all the cutting oil and stuff that they use, that stuff gets atomized, and it's just floating around in the air. And if you unconnect a fiber optic connector, it could settle on the end of that. So that's one aspect of where oil can come other than from your hands, and just being in the environment. Liquid, and we're talking about any kind of liquid. We're talking water, we're talking alcohol, we're talking solvents, anything that's got any type of a liquid. Scratches, it's pretty self-evident. Scratches on the end face of the fiber usually means one of two things. Your connector fell on the ground, it wasn't properly polished, and that can cause all kinds of issues. Chips or pits, this mainly has to do with when your protrusion exceeds the spec and it wasn't caught, and you get two connectors that are mated together and that fiber sticking out further than it should have, and what happens is the actual glass, since they touch and make that physical contact, kind of explode or char, and can cause a lot of problems, and that'll basically ruin your connector, and you either have to replace the patch cord or you have to repolish. And then, excess epoxy, that'll cause issues where it'll actually keep that physical contact further away, and it'll give you a little bit of an air gap. So we got to make sure that all the epoxy is polished off when you're, if you have to re-terminate a connector in the field, or you get a patch cord and hey, it was supposed to have been passed, but there's still some epoxy. Sometimes you can hand polish that off, but generally, if there's epoxy there, more than likely a step was missed from your manufacturer from where you got the cables. So it's pretty basic. Any kind of contamination in the fiber system can cause problems, attenuation, back reflection, and it can really be the root of what your problems are in your network. Even microscopic dust particles can cause problems. Like I said, we're talking micron levels here. 1, 2, 3 micron size pieces of dirt, dust, contamination can really play havoc in your network. And this contamination is going to block the signal. give back reflection, and you know, it's just, and actually what happens is if you get strong enough back reflections, they would basically reflect back into the laser, and that can damage the laser. And in this case, like it says, it causes instability, but mainly you can damage your laser. And any type of contamination that's between two fibers, and that constantly is mate and demate, can actually scratch the glass, meaning the fiber optic cable portion of it, or they can scratch the ferrule, also the ceramic end face of the ferrule. So there's contamination, and so situated at the cladding or the edge of the end face. Generally, that's epoxy, and that's what I was talking about. It can make an air gap because that physical contact is not coming. The two connectors are not coming together, and that can cause again back reflection and attenuation. So here's a good little rule. You know, you can think about it. You know, if you're using a single mode cable and you got a 1 micron dust particle on a 9 micron core, right off the bat you could be losing 10% of your signal. So that's a high percentage of it. So that's why, you know, when we're talking these dust particles, which most of them are on these micro levels, trying to get them as pristine as possible is really key. You know, and that's the other thing. You can't see any of this dirt that I'm talking about. You know, that we're on the micron level. You can't see it without a microscope or an inspection scope. So you can take a look at it and say, oh, it looks clean, but you won't be able to see it unless you really take one of the pieces of equipment, whether it's the video inspection probe or the microscope. You really have to have that in your tool bag in order to determine if your fiber connections are clean and free of defects. One thing that you want to remember too also is if you're working in high-powered lasers that are throwing out a lot of radiation, if there's any contamination on the end of it, it can actually burn the end face of the fiber, and it'll actually burn that contamination onto the end face, and that cause back reflections and attenuation, and in theory it could damage the laser. So especially with your larger core, you know, your multi-modes, but they are sending with that larger core, they may be sending out extra power, not seen as much so in the single mode, that you can come to issues with just because there's a little bit of dirt that's blocking that core. So that's important, especially for high-powered lasers. And you can see it burns and damages the optic surface enough that it can't be cleaned, so you'll have to either re-terminate or get a new patch cord. And hopefully you didn't ruin your equipment. Yeah, this is the basic thing. Just you make sure there's dust and contamination. You got to have a clean environment. It's very important. And you know, if you take that extra time to clean, it could save you down the road trying to find what the problem is. You know, which is, you know, stressing this clean, inspect, and reinspect. You know, as you're going to see in the one of our next slides, kind of a little chart that tells you how to kind of go about inspecting. So here's going to be a little bit of, this is a neat little slide here that will show you, you know, you have this connector base here, and you're going to mate it with you know, a clean connector. So one of the things that you got to remember is when you clean one connector, you really should make sure you clean the opposite connector that you're going to mate with, because this is going to demonstrate why you should do that. So we've got a connector here that's got dirt on it, but we clean the one connector that's coming in from the right-hand side. So you can see it's clean. Okay, so what that did was it kind of caused all the dirt there in there to explode because of that pressure that I said before, that 45,000 psi is coming in. And what it does is actually makes more, you know, more dirt, makes it spread out. You come in again, you can see some of the pieces are left on the one that's pulling away, but you're continuing to mash this. And what this is doing is it's mashing the fiber, the dirt, whatever, excuse me, the dirt contamination into the fiber and also into the ceramic ferrule. You can see it's doing it again. And see, as it's coming off, that's what transfer is. So you can have a pristine connector that you connected with a connector that had dirt on it, and now you have dirt on both connectors because of transfer. and that'll just keep doing it. So that's one thing you got to remember. That's why you clean both connectors before you make them. Even if when in doubt, just clean and inspect. So this is showing you what a pristine end face should look like. And this is actually a single mode fiber. The small dot in the middle is the core. The dark is the cladding. That's the 125 micron cladding around the 9 micron core. In this case, you're seeing that it's a 200x magnification. And you can see when you use the 200 scope, you can see more of the ferrule end. That area beyond the cladding is all the ceramic. So you get to see more of that. So that's one of the one things you want to know with the 200x scope. It's not going to magnify as much. So here's another shot, and this is a relatively clean photo here, or I should say end face, except for that, on the right-hand side, you see those little black dirt dots, whatever you want to call it. That could be, that's in the epoxy ring area. That's where the epoxy meets the ferrule. That could be excess epoxy. But for the most part, this may pass the inspection, the pass-fail, but it may not. So it couldn't hurt to take a look at that and throw it on the pass-fail inspection software if you have it available to you. That there is a picture of a multi-mode cable, and you can tell by the larger core size in the middle. It's probably a 62 125 fiber there. So now we're going to show you some pictures of what you would expect to see by the picture to tell you what kind of contaminant you're looking at. So the first one is obviously it's dirt. You can see the specks that are all over, and dirt's pretty generally evenly distributed around. There's no real pattern, but it's there. It's all over the place. And you can see some of those larger pieces of dirt. If they're on top of the core, you're going to lose a lot of signal. So that's something to look out for. You definitely would clean that, and it should come up. That would look pretty good. Second picture is it says alcohol. It could be solvent. It could be any type of liquid for the most part. And it almost looks like, if you look at those lines, they're smooth, they're kind of wavy. Almost looks like they're still flowing, and that's because that's still wet. It's not dried solvent or liquid. And that's a telltale sign that it's still, if you would actually watch that under the microscope, it's going to dry up, and it's actually going to look like the bottom right hand. When I show you the next two slides, you'll see what it actually probably would look like when it was dry. This picture, it says scratches, and I'm going to tell you right now, it's an illustration to show what scratches look like. This is actually a fiber that is in the midst of a polishing process. This is probably like the second or third step in polishing, just to show you what scratches look like. But you can see those scratches, and you can see that large dark ring. That's epoxy that still needs to be removed from this end face. But it's a good illustration of scratches. So now you see this bottom photo here. It shows that it's dried up. That from the top picture that showed it was like wavy, it looks like river, looks like moving water, down to where it droplets. It still might even, you can see there's a little bit of ones that look like they're in there that it could still be wet. They're still drying, but that's how residue. Because the other thing that does is in that liquid there's also dirt that was trapped in there, so that'll dry and that'll stick on the end of it. So again, you want to clean that. Dust particles, just shows more dust particles. Now, the good illustration of this is if you get the one large, there's a couple large pieces in the, off to the right, top right, and middle to bottom right. If they're over top that small core in the middle, you're not getting any signal through. So just remember that. This is more liquid contamination. Again, it's not dried, but the one thing that you want to note here is this cable was mated with another cable. And the reason you know that is that it almost looks like a dotted line in a circle. So what happens when these two connectors come together and they touch, it actually makes that physical contact. The glass flattens out from the two connectors on each other, and the ceramic touches. And what it does is it pushes the liquid or the contaminant away to where there's no connection between the two ceramics, and that's where it stops, it dries, and you can see that's why it's like a circle. It's almost like it's a footprint of two connectors being connected. This again is more liquid, still not dried, but probably what happened, somebody could have wiped this with alcohol and then didn't do the second step or to dry it off, and this is what happened. So they looked under the microscope and it's still not dry, but they, it still needs to dry up, but they should have cleaned it off with another brand new lid-free wipe. Again, here's another liquid contamination. Now this one's pretty clean, but you can see that dotted circle. Again, there was liquid on here, and it was mated with another connector, and it was set, and it was left to dry. And here's other. This looks like it's an alcohol with that residue. That all alcohol, when you're cleaning, alcohol is good to clean with, but alcohol usually leaves, if not dried properly, will leave a residue. That's why it's better to kind of. Alcohol is good, but a fiber optic solvent that's designed for this application is a better step to use than just plain alcohol. Again, dry residue. We're really hitting home on, that this looks pretty good. There's no contamination on the cladding or the core. You can't see the core here for this particular one, but you really should get rid of that ring there. And also, if you can see in the bottom right, it looks like there's a line that's drawn down. That's a scratch. It's on the ferrule. May not cause any issues, but it's nonetheless, that's what a scratch would look like. And this is oil residue on a single mode connector end face. And the reason you know that it's oil is they're kind of parallel lines. For whatever reason, oil dries. I'm sure there's a physics reason. But when oil dries, it dries, and there's these parallel lines that is indicative of oil. That's from somebody's hand was touched, or even, believe it or not, when they were cleaning off the fiber end face and they had their hands that had oil on it, it got too close to that. It can transfer actually even through the lint-free wipe sometimes. So that's sometimes people continue to clean. They're like, why? Where is this coming from? It's because of the oil from their hands. So here's a really good picture, and it shows scratches. There's scratches through the core, through the cladding, and also on the ferrule end face of ceramic. This probably is how it was received from manufacturer, and it somehow got through QC. But the good thing about this is, with the video inspection probe, before you hooked it up, the technician caught that there were scratches on this. So, that's why whenever you get a brand new jumper that's in a bag, you got to assume that there could be something wrong with it. That's why you want to inspect it, because you could have put this into the system and not looked at it, and it could have caused problems. And then you run around chasing your trail, try to figure out where's the attenuation coming from. When if you inspect it before you connect, it would make a big difference. This is damage. This chipping is probably a result of a protrusion, or in this case, that extra dark rings around there. That's extra epoxy that was not cleaned off. So again, it's raised above the ferrule, and it was another ferrule came in and smacked it, and it caused chipping. And that probably it fractured the fiber down there, because that's right along the epoxy line in the ferrule. So that's again. Inspecting this beforehand, I would not put this cable in circulation. I would, reject that and get a new one, and again inspect it before I connect it. This is a 1.25 ferrule, as it says here, and it was overpolished. What happens when they say it's overpolished? It's probably very pointy, and it probably fails the IEC spec. The fact that you can see that dark area in there, it doesn't conform to the specs that it needs to be, and probably needs to be replaced or repolished. So now we're going to try to get into cleaning procedures. Here's just a kit. It shows a bunch of different cleaning products. There's dry method, there's wet method, and then I'm going to now go over those. So actually what we're going to do is this is a chart that basically is used for, it's a flow chart, how to clean. So you start, spec the end, just figure you're taking a patchboard out of a plastic bag. First thing you should do is inspect the end face with the fibroscope and or video inspection scope. Is it clean? If it is, you're good to go. You can plug it into or mate it with your other connection and then do your testing or whatever. If it's not, you want to use, first always start with dry cleaning because that's, the easiest. You don't have to open up your solution or whatever. Try the dry clean. Inspect it again. Is it clean? If it is, you're good to go. Move on. If not, you want to try another dry clean again because on the first one you could have gotten rid of some of the debris but not everything. So you do a dry clean again, you inspect it. Is it clean? Again, if it is, you're good to go. If not, this is where you want to probably bring in your wet method combination. Use a little solvent, lint-free wipe, and then inspect it again. And that's sometimes you get some stubborn dirt that's really ground onto the end face, and you need a little bit of solvent to help you get that off. And then you can plug it in and you can clean it. So what we have here is we came up with an acronym, to kind of, it's kind of an interesting little side note. We were thinking about this and we came up with it during the summertime. So that's kind of why we named it ICE-T. You inspect, clean, you evaluate, and test. One thing you want to remember about the evaluation, that's the evaluate, because a lot of people say inspect, clean, inspect, test. The evaluation portion of it is where you have to continue to go back. If it's not clean, you're going to go back and try cleaning it with the dry method. You do maybe 1 or 2, maybe 3 dry methods. If that doesn't work, then you work in the wet method. So that's where we came up with the ICE-T method to remember to inspect, clean, evaluate, and test. Now, these are the different types of dry methods. You got your cassette cleaners, your lint-free wipes, and you've seen the single wipes, and also the box cubes that are out there. Cleaning sticks, both 1.25 and 2.5 millimeter. And you got your quick clicks. A lot of people call them one clicks. One thing that you got to remember about those, it's a single click is a single cleaning operation. It doesn't mean that it's one click and you're clean. So that's important to know. And then there's your wet methods, which is you're using the solvent with some of your dry methods, your lint-free wipes, your cleaning sticks, and then your solvent. There's a couple different types of solvents that are out there. There's fiber optic cleaner that's a solvent-based. There's a water-based now for the environment, and also there's the alcohol. But you got to remember, use that 99% pure stuff. It'll still leave a residue, so you have to use the wet and then dry it off at the end. So this just shows, if you weren't familiar with the different cleaning methods, we'll start top left at your cleaning cassette. That little silver thumb, you push that down, it advances and opens up the window. You only wipe in one direction with your dry connection, and then inspect. The next one over, you got your lint-free wipes, and they're pretty self-explanatory. But the main thing is there's no fibers that are coming off that. That's what's the main thing is with them. And you have your cube cleaners where you open that. It's almost like the lint-free wipes, only it comes in a roll and you can wipe it on that little box. And then the bottom, you got the 2 types of cleaning sticks, 2.5 millimeter, 1.25 millimeter. Again, you can use with solvent or without. Then the middle, you got that says a Pro CS125. It's a 1.25 millimeter quick click. Can be used for cable assemblies, and you take off that clear plastic tip on the end, and you can use it in bulkheads. And then the one below that is for MPO connectors. We didn't really go over those, but they're at 12 fibers in one connector. A lot of these are found in the data centers and stuff like that, or gas environments. So they're up and coming. So that's it. Just like it's a quick click for a different type of connector. And then your wet methods, as I said before, that's pretty easy. You're using the solvent, the optic cleaner that's designed for cleaning with your lint-free wipes or your cleaning sticks. So here's some things to remember when you are cleaning with solvent. you don't want to let it evaporate, as I said before. You clean with the wet, and then immediately bring it over to a dry area on that lint-free wipe, and wipe it, and that'll keep that, as you saw in the slides before, that where it looks like it's still wet. And you can do the same thing with the cleaning sticks. You put a little bit of solvent on the cleaning stick, clean it, and then bring a dry one in to kind of dry that up. It's extremely difficult to clean off with another wet cleaning. So once that residue dries, then you have to bring the wet in again. So you might as well wet it and then clean it off with a dry, and it kind of saves you a step. The other thing, especially when you're cleaning in the bulkheads, when you're using the cleaning sticks, there's a lot of areas for, once you put it in for it to hide, and you won't get it out. And that's why you go back in with a dry one, and that kind of sucks out, gets the excess solvent that you have in there. One thing you want to remember, just when using solvent in general, less is better. You can always use it again, but the less you use, the less you have to remove. Pretty self-explanatory. Cleaning method is 100% effective, but you just got to make sure that you clean once. The main thing is you're expecting afterwards, and that'll tell you, did I get it clean? Improper cleaning methods, you can ruin your equipment. It's pretty self there. You don't want to scrub the fiber against the wipes, meaning back and forth. You want to go in one direction only. And kind of keep the connection perpendicular, or the connector perpendicular when you're drawing it. You either draw it towards you or draw it away to be consistent. Do not run over the same area once or twice. You can transfer dirt, pick up new dirt, or you can ground in the dirt into the fiber. Storing of these, keep your cleaning supplies clean. Don't have them laying around where dust can get on them. If anything has end caps or caps on them, keep them closed. That's why lids are there. You avoid contaminations, with other fiber during the connection. So you want to keep stuff, your dust caps on your cable assemblies, keep them on there until you're ready to connect after you've inspected. Some safety tips here you want to look at. Pretty self-explanatory stuff. The big thing is don't ever look into fiber when you think the lasers are on. Always think that the laser's on. Never assume that it's off. You never clean the bulkheads with receptacle devices without a way to inspect them. So that's the one thing you get. You can clean it, but you don't know if it's clean without an inspection probe to take a look at it. This is when working with electricity, when you may be around electricity when you're working on the fiber cabinets, because there still may be power, so be grounded. Again, this is, using unfiltered hand fires or focusing optics. Just don't look into the end faces, if you think that the power is still on. That's why the one good thing about using inspection probes, video inspection probes, is you can look when the power's on, because looking directly into that, it's looking through the inspection probe, and then it's displaying it on a display. So best thing, this is mainly when you're talking about handheld fiber microscopes. You don't want to touch the end faces. You don't twist or pull in the cable. You always want to grab on the connector housing. Yeah, you use one lint-free wipe once and then get rid of it. They're relatively cheap, so use it once and get rid of it. Same with the cleaning sticks. And then you can. It says never touch the clean area of your lint-free wipe. That's for when you're you're cleaning. That's because you can get oil transfer from your hand onto the cleaning area and then onto your inspection connectors. Alcohol can start fires, so be careful. Here's some stuff that you always want to. This is kind of like the safety stuff, but make sure the laser's off. Always make sure that the cable is disconnected both ends if you're or plug receivers moved, because you don't want to have the laser transmitting when you're cleaning, and then it can send a back reflection back and damage your equipment. Wear your safety glasses. That's great. Can't hurt. And if you you're working around, where there's lasers radiation, make sure that you have approved safety glasses. Inspect connectors and adapters before you clean. That's a good thing to do also, just so you know what you're starting with and you know where you're going to. That's what we've been talking about all along. Again, we said this in the safety portion of it, otherwise you could damage your fiber connection. Keep those the dust caps or protective caps on your fibers. And this, the reason you want to store the protective caps in a resealable container so they don't get dust and dirt and stuff just by laying out in the open. And always get rid of your stuff correctly. And that draws to conclusion the webinar here. If you have any questions, I will definitely try to answer those for you. Okay, I got a connection. Oh, here we go. We got some questions coming in. And I'll read up. Excuse me, you may not have heard me, but is it possible that dry clean could cause scratches? It is possible that dry clean can cause scratches if there's dirt or debris or stuff on those cleaning media before you go to clean your connector. So that's the one thing where we were saying keep everything closed, and from your cleaning supplies, if they're in a container or in a plastic bag, keep that closed, because you want to eliminate the amount of dirt that gets on those. Nothing is 100%. So the main thing you want to do is, because what will happen sometimes is, I've seen it before, is the guys are cleaning in the field and they have a pack of these wipes and they drop them on the ground. And they pick them up, just not thinking anything of it. You could have gotten dirt inside that bag, dust, whatever, and in dust there could be fine sand particles, that are, and that's like sandpaper. So yes, that is possible. So you just got to make sure that it's more of a housekeeping type thing. Keep your cleaning supplies clean, as well as using them to clean your fiber optics. I hope that answered your question. Got another question here. Can you show the last slide again, please? All right. Good. Is that the slide you were talking about, Mike? Okay. Did you have a particular question on that slide? Okay. All right. I got another question here, and this comes up a lot of times when I'm out in the field. Does the probe for the inspection probe need to be cleaned, and does the probe transfer over dirt? It always comes up. It's funny. I get this question, I think, every time I do one of these talks or I'm out demonstrating these in the field. If there's no physical contact with the microscope onto the fiber end face. It's all done with lensing and the focal point. So there's an end tip that goes onto the end of the fiber inspection probe, and then your connection goes in there. There's probably about a ½ inch gap between the end face and the lens of the inspection probe. So if there's any dirt that's on the lens, it's actually out of the focal point. So you don't have to worry about dirt on the lens. And since there's no physical connection between the end face of the ferrule and the connector and the microscope probe, there's no issue there. Now, occasionally, you drop this, and you can get dirt on the end of the face. Once in a while, you can go through and just take a lint-free wipe and wipe it over on the lens that it's on the end of these inspection probes. But for the most part, you're not going to have any issues with that. And again, the dirt, if there is any dirt on that lens, it's out of the focal lens range, and you will not see it, or focal point, you won't see it. I got another question here. Oh, wait a second. How can I have this? Hold on 1 second, please. Sorry about that. I had some technical issues here. If you look on the slide that I have up now, if you go to the fiberoptic.com/webinar and you look for the presentation that we did today, inspection and cleaning, you can get the webinar there, or the slideshow there. Another question I had here is, how do you clean a bulkhead properly? So that's, the best way to clean your bulkheads is to, make sure that you take both connectors, unmake them, and then you can generally, if it's a 2.5 millimeter adapter, you get a 2.5 millimeter cleaning stick. You can do it dry first. Maybe you want to do a combination of a little bit of wet, clean it through there, and then bring a dry one in to dry it out. There's really no way of inspecting a bulkhead, the actual bulkhead. But in theory, there's no contact that's made from on the end face. It's just the side with that split sleeve that aligns the two ferrules when they're pressed in there from the connectors. Sometimes dirt can get lodged in the split sleeve where there's a gap. So cleaning it once in a while cannot hurt, because sometimes that's an area which you will get buildup. On some of the older or even the multi-mode adapters, they're made of a phosphorus bronze split sleeve, which is a metal versus a ceramic, and that phosphorus bronze coating, it helps aiding in the sliding. That'll rub off sometimes. So in multi-mode applications, you're going to see more issues caused by those adapters than you will in the single mode that have the zirconia split sleeves. So that's always a good thing to remember. Let's see, okay, there's another question. Can you use a Fiber Inspection Pro to check a jumper for breaks or problems? In this case, you cannot do that. Pro is only used to inspect the end face. If you're looking for breaks in a system, you could use a VFL or an optical fault locator. So that's kind of off topic a little bit, but yeah, it's really not a tool that's used for detecting breaks in a fiber network. So I don't see any more questions. So if you do come up with questions, later today or whatever, or down the road, feel free to send a question to training@fiberoptic.com or even sales@fiberoptic.com. You can reference this webinar. You can even reference my name, because then it'll be directed towards me, and I'll be sure to answer you directly. And you can even ask for me, and I'll talk to you if you have issues. It's not a problem. So I think with that, that concludes our webinar for today. Again, Joe Cairone is my name, and I hope this was very informative for you today, and I thank you for joining my webinar.